Holy cow, what a flea market find. Check this out. It is a precision timer that does 1/100th of a second and goes up to 60 seconds. Just by its appearance, you know this thing is going to predate solid state by some considerable amount. So it's going to be a lot of fun to take apart and see if I can get it working. Yeah, Standard is the brand name. Standard on the back, and we got this plate on the bottom. The Standard Electric Time Company. That is a venerable company, if there is any. Springfield, Massachusetts. This company was formed like in the 1880s, in early 1880s at that. And they got on to making electric clocks early on. The actual timekeeping, they did master clocks, which used a pendulum type of mechanism to keep the time. Is before quartz crystal oscillators or GPS or anything like that. And but they used electricity to take the master clock and set slave clocks all throughout the building. The Standard Electric Time, virtually the majority of clocks that were in institutional buildings, universities and schools and government buildings for the first half of the last century, they were made by Standard Electric Time Company. Yeah, this company, it was in existence, or it sort of is still in existence, not really. It was in existence for about 100 years. By the 1970s, their timekeeping division had wound down, and they were mainly making fire alarms and building type of stuff like that, like building automation things. And they were bought out by one company, and then bought by another company, and they ended up in the hands of the multinational Siemens company. And Siemens still has an outlet or a little field office in Springfield, Massachusetts, which I suppose is the eventual fate of the Standard Electric Time Company. It's a little bit sad that their field office looks pretty insignificant. Anyways, the Standard Electric Time Company, they made master and slave clocks, they made tower clocks, and they did a few standalone type of products, and this is one of them. They made these timers, and these date from the 1950s. I found one manual on eBay. These timers you can find on eBay, usually in crappy condition. This is beautiful. I found a manual on eBay. 1955 was the date for that. Very cool manual. It has the wiring diagram, so I can fix it up, hopefully. And it has a parts list, and that was kind of neat to check out. The movement inside here, in the parts list, a replacement value in 1955 dollars was $72, which today is like close to $700. Yeah, this is in its time, it was a pretty sophisticated piece of equipment. If we look at the nameplate, we can see a few things before we crack it open. First of all, it is type S-1. That's, I think, the precision that it keeps. It has a motor and it has a clutch, both of which are electrically operated. So the motor is gonna make the hands go spinning around, and the clutch it would be connected to a wire that comes out the back, and it has a switch on it to start and stop the timing. This is a manual reset lever. Because the hands are already in the top position, that reset's not actually doing anything right here, right now. Anyways, very cool. Let's take this thing apart and see if we can see what makes it work and see if we can get it working. Stick around. So we have 4 screws on the back, and they are flat heads like they all were in the old days. And let's pop the back off and check out the insides, and it looks like some little bird was making a nest in there. It looks remarkably clean, however, so that's promising. Yeah, I wonder what sort of plastics they used back then, because, well, this 1950s, the serial number on the back begins with 53. I wonder if that might be the year of manufacturing. I have no way to know whether that's the date code or not. I wonder what sort of plastics they were using. It's a very hard plastic that doesn't scratch easy. You can see by the feet here. I kind of, the first thing to think is Bakelite, but Bakelite, I don't believe that they made complex molded parts out of Bakelite. There are not many plastics that were around. They had polystyrene and they had vinyl. Another possibility that it is melamine, because melamine is also moldable. Yeah. Bakelite is generally difficult to make really complicated parts like that. At least that's what I understand. Well, let's run a couple tests and see if we can figure this out. To figure out whether it's Bakelite, you can use a cleaning product called Scrub and Bubbles, which almost everybody has. And, well, Scrub and Bubbles has an ingredient in it that reacts with the Bakelite and can turn yellow if it's actually Bakelite. I gotta go up and I gotta raid the cleaning cupboard. And I hope that my wife doesn't see me, because if she does, if she sees me looking in the cleaning cupboard, she's gonna assign me some sort of a chore. So, wish me luck. I'll be right back. Oh, fuck. Sure enough, I was caught. Now I gotta recock the bathroom sink. Well, tomorrow. Anyways, I got the Scrub and Bubbles here, and let's get a Q-tip and get it nice and moist. See what happens. Supposed to just rub it onto the plastic for a little bit. You do it on an inside surface. It's not supposed to damage the Bakelite, but people still say do it on some surface that's not going to be sightly. And it's not turning yellow whatsoever. So that's probably not Bakelite. I didn't expect it to be Bakelite. Melamine or plastic? If it's plastic, it would melt. If it's melamine, melamine's thermoset, meaning that once it's been molded, it can't just be reheated and remelted. So I got a soldering iron here, and I have it set to 650 freedom degrees, and let's see what happens. Yeah, not even hardly touching, just making some marks on the surface, not melting it whatsoever. Yeah, this I imagine that it's melamine. Got any other ideas? I'm really curious. I find it fascinating learning the history of manufacture of these electronics. Anyways, let's take a look at the inside of this thing. Oh my goodness, that is one wonderful odor. I love the smell of vintage electronics. It's because of my childhood. My dad, he'd bring me home all sorts of crap from work that I'd take apart. Man, I remember one time, it was like friggin' Christmas morning in July. He brought home the local telephone company's switching computer. My eyes lit up, and holy cow, that was so interesting. I was only like 6 years old, no, 8 years old. I didn't know what the fuck I was looking at, but it was cool. And he pointed out, that thing there, that's core memory. I took that apart, and you ever see core memory before? It is so cool. You can actually see where the bytes are stored. They have to be wound by hand. Anyways, let me unscrew the innards and pop this out. Again, flathead screws. Flathead screws. flathead screw use. And don't. I'll take that off too. Wow, behold that. There is not a circuit board or anything solid state in sight. We got a synchronous motor here, General Electric, synchronous inductor motor as the RPM label. I love how they stamped things back in the old days indelibly. Even the silk screening is in mint condition. Wow, that is so cool. And a wiring diagram. Okay, yeah. There's another one on here. I think I'm going to actually rely on the ones that I see on eBay in that instruction manual, just to make sure that I get this right. Yeah, we got a synchronous motor here. The 3 wires coming out of it, meaning that it is 2 coils, and one of the coils is attached to this capacitor. And that's going to create a phase delay, and it's going to make that motor do its spinning, thinging. And here we got another coil with a couple wires coming out, and that must be that has to be the clutch. I see in there. Let me get a pointer. You see in there is a toothed wheel, and that toothed wheel is being held in place by the clutch pawls. You got one pawl there, and you got another pawl there. And when that electromagnet does its thing, it's going to pull those pawls away from that toothed wheel, knurled wheel, and it's going to allow the synchronous motor to drive the hands, and there's just a couple of gears up there for doing the 100 for the big hand, 100 a full revolution for only a 1 second revolution, or 1/60th on the red hand. Yeah, in addition to that, we got the reset lever here. And the reset lever actuates a cam type of reset mechanism. See like that, so that pulls that back. Anyways, that is pretty cool. It looks like it's in remarkable shape. I'm just going to test this capacitor and make sure that it's not way out of whack. And I am going to wire this up. I'll be right back. Now, the capacitor checked out fine, and the rewiring was pretty straightforward because I got these point-to-point soldering terminals, and on the plate there is actually a threaded hole for 632 screws, so I could have a very convenient place to mount that. Yeah, it looks not too bad. Well, I suppose. Looks a little bit like a bomb wiring, so I better do a sanity check and just make sure it's not going to blow my circuit breaker when I plug it in. Okay, I got the meter here set to ohms, and let's 476 ohms. Well, here is my remote control that I wired in, and that is off. So that's just the motor winding at 1.8 kilo ohm. It'd be just one winding. The other winding is through a capacitor. Yeah, looks not bad. All I gotta do now is clean it up, give it a little bit of oil, and throw it back together. There's some nice synthetic watch oil. You use this very sparingly. Generally, it's just little tiny drops at the end of a pin. Get some on the pawls. Anyways, I'm going to finish oiling it up. I'm going to put it back together, and I'll be right back. Okay, back together. Now, listen to that motor purr. Awesome. And yeah, that is so cool. Anyways, thanks for watching. Take care. Bye-bye.